This video will cover Chapter 23, Inferences about Means, Confidence Intervals. We're resuming the question that we were working on in the previous video with hypothesis testing, where we are in my dream world, where there's a coffee vending machine everywhere, particularly in the faculty room at Boas, and this machine in particular is supposed to pour a 10-ounce cup of coffee, but since I suspect that I'm being shorted, and who would want that, for 20 days I gather evidence. And so we saw the evidence here, and we put it into our calculators over here, so stat edit, and there's all of our data. In order to create a confidence interval, and let's just say for this time we're going to make a 95% confidence interval. Before we do any confidence interval, we have to make sure that our conditions have been met. So I've actually already just copied the ones that we checked in the last video right here, because they are exactly the same for a confidence interval. We want to make sure we have a representative sample of cups of coffee. If possible, we want it to be a random sample. I don't know if this is a random sample necessarily, but I have no reason to believe it doesn't represent all the cups of coffee that are coming out of the machine. I presume that 20 is less than 10% of all cups of coffee that will come out of this machine. And then we also check to make sure our sample is approximately normal, or that is unimodal and symmetric. We did that by going to stat plot, made sure our plot was turned on. We're going to make a histogram from list 1, press zoom 9, and there's our plot. And then we just copy that graph right onto our paper to prove that we actually did check that condition, and it's unimodal and symmetric enough, so we're okay to move on. And remember, the reason we had to check this condition was because our new model that we're using, the T model, does not work, especially for small sample sizes for skewed populations. So since we don't know necessarily about the population, but we have the sample, we can check to make sure that our sample is not skewed. All right, so now that our conditions are met, we're ready to move on to do one sample confidence interval for means. It's okay if you call this a one sample T interval. And just like any confidence interval, we're going to create it by taking a statistic and adding or subtracting a margin of error, which is made up of a critical value times a standard error. All right, so to make it more specific for that margin of error should cover the whole thing. And to make it more specific for this type of problem, our statistic is the y bar, our mean, and our critical value is no longer z star. That was reserved strictly for the normal model. So it's going to be called now t, because we're using the t model, and we have to note how many degrees of freedom, and that's so sub n minus 1 star. That's our critical value. And in order to calculate standard error, we're going to take standard deviation divided by the square root of n. All right, so let's just make sure that we've pointed out exactly what each of these values are. So going back, remember we had from our calculator stat calc 1 var stat. We knew what our y bar is, 9.845, and we know what our standard deviation is for the sample. So we're just going to call that out next to this. We're going to say y bar is 9.845, and our standard deviation is 0.199, and our n, of course, is 20. So that means our critical value is something that we have to figure out. We always have to report everything that we're going to substitute into our equation. So our critical value we can find in our calculator, but many of you will not, just like on this calculator that I'm using here, will actually not have the formula there. Usually we would go to second distribution, and just like we had an inverse norm, we would want to use something like an inverse t, because we know the area that we want, and we would want to use our calculator to figure out what that critical value is. But see, I don't have that on mine, even if I scroll down. And so what we'll do in class is I will give you guys a program to use in your calculator. But there is a backup, so if we don't have the program, let's go to our formula sheets. Remember these? All right, so I've actually already scrolled down in our formula sheet. These are the pages you're normally looking at. All right, but in the back are all these tables that we hardly ever use. And I want to scroll down to the table that says t-distribution critical values. All right, and so I'm going to actually zoom in a little bit so that we can see it a little bit better. And this will give us our critical values. And it's going to give us a one-tail probability. That's what we're going to use. Since we're doing a 95% confidence interval, we know each of our tails has 2.5% or 0.025 in it. So we're interested in this column right here, 0.025. And on the left side are the numbers of degrees of freedom. And remember, our problem has 19 degrees of freedom. So we're going to read over the row 19 to the column 0.025. And we see that the critical value that we're looking at is, let me just make sure I'm reading this correctly, 2.093. All right, so we're going to copy that over to our paper. And now we're ready to calculate the confidence interval. And there is a button for this on everyone's calculator. We can go to Stat, Tests, and we're going to scroll down. All right. Why did I scroll down so far? Okay, we want a t-interval. All right, so we're going to press enter. And again, we have data. We could also do the same thing if we had the statistics. I'll just show you what that looks like. All right, so we would be typing in the specific, ours are already actually there, so we could type in the specific statistics. But we have data, so we're going to have it read in from L1, and it's already going to do a confidence level of 0.95. So we're going to say calculate. So after much work and thinking, here we go. We know that our interval goes from 9.752 to 9.938. All right, so now we're ready to draw a conclusion about our interval. So that just means stating our interval in context, and this looks very similar to what we've been doing. We can be 95% confident that the true average amount of coffee from the vending machine is between 9.752 and 9.938 ounces. And so normally that would be the end of our problem. Sometimes though, we are asked to use a confidence interval in order to perform a hypothesis test. So I'm just going to reiterate how that's done. We did that with proportions as well. So remember, my null hypothesis was that the mean was 10, and my alternative was that it was shorting me coffee, so that the mean was less than 10. All right, so when I look at my interval falls completely below 10, which is exactly what I'm looking at here. Every value in my interval falls below 10. So my interval allows me to reject the null hypothesis, since my null value does not fall in my interval, to say that the alternative is possible, to accept the alternative and say that the coffee machine appears to be shorting me coffee. All right, so I reached the same conclusion when we did the hypothesis test as well. So remember, this range of values, it doesn't matter where you are in your range, it's that every single possible value within that range could represent the true mean. All right, so that could be 9.752, and that could be anything in between. All right, so that's how we would use our confidence interval to perform a hypothesis test. And that is the end of this video.